Now see, B is in which column and which row? B is the first row and second column. So leave the first row and second column. What is left out? D, F, G, I. D, F, G, I plus. So plus minus plus plus C into, check what is left out. C is the third column and the first row. So leave the first and the third. What is left out? D, E, G, H. D, E, G, H, and then evaluate it. You know how to evaluate the determinant of order 2. Okay. Now to just begin and make you understand better, I will give one example. Okay. Let us take a determinant, say 1, minus 3, 2, 0, 1, 1, 2, minus 1, 3. Okay. I just took a determinant for you, and let me just show you how to evaluate this determinant. So as scheduled, I am taking the first row as the base row and opening up the determinant. You can take any row, any column and open the determinant, but the sign convention of the first row is plus, minus, plus. So if you see this here, plus, right, minus and plus. So follow that same convention here. So let us see how we go about it. So first, look at this pattern, which is equal to 1 into its minor. Now what is the minor here in this case? Just understand what is the minor. 1, leave that row, leave that column. 1, 1, minus 1, 3. 1, 1, minus 1, 3. Right? Then second, plus, minus, plus, because I am taking the first row and opening up. Minus of this. So minus of, right? Minus of minus 3 into. Try to understand what I am doing. Minus 3 in the second column and the first row. So leave the first row and the second column. 0, 1, 2, 3. I think 0, 1, 2, 3. Similarly, plus 2. Plus 2. See what I am doing the sign. Plus, minus, plus. Plus, minus, plus 2. Okay. Then you just put across the values. So if I take the third column and the first row, 2 comes over here. So leave that row and leave that column. 0, 1, 2, minus 1. 0, 1, 2, minus 1. Now I can evaluate it very quickly. This is 1 as it is. So this is nothing but AD minus BC. So 3 plus 1. Minus of minus 3 is plus 3. Right? 0, 2 ones are 2, minus 2. Plus 2, 0, minus 2. So finally you have to just evaluate this. This is nothing but 4 minus 6 minus 4. Check it yourself. Right? So I think 3 1 plus 4, 3 2 is 6, minus 6, and 2 into minus 2 is minus 4. So finally you can get. Hello there. So you had seen what is a determinant. You had seen how to evaluate a determinant of order 2. You are aware of how to evaluate the determinant of order 3. Now one more small concept is there in determinant which you need to understand and know. What is a minor and cofactor of elements of a determinant, of course. So basically, before we proceed, I want to just educate you on this point. Now I am talking about an order 3, okay, order 3. So let us take the position of the elements. Now order 3, remember this is the first element, A11, A12, A13. So what does it mean? First row and first column, first row and second column, first row and third column. Similarly, A21, A22, A23, A31, A32, A33. Now please understand, this is nothing but the position of the elements. The position of elements. They are not the value of the elements, okay? So don't get mixed up. Now what I am going to share with you is the position of the elements is done, okay? Now I am talking about minor. Now let us talk about minor. Now before that I will just mention this thing, okay? Now what I will do is I will just write what is a minor in the fact. I'll just show it to you. It becomes more easy for you all to understand. So let us take an element here. Okay, let us take an element here. Determinant I'll give you. Say 1 minus 3 2 1 4 3 minus 1 2 1. Okay. Now what I'm going to do is I am going to explain to you what is a minor of an element. Okay, so I'll just take 4-5 examples. I need not put. For every element you get a minor. Now how I get the minor, that is what we are going to see. Now suppose if I want to find the minor of M11, M23, M22, M31, M33. Now remember 1 1 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3 3. Now this is the position. So this is the position of the elements which is given over here. Try to understand. 1 1. So first row, first column. So tell me, where is first row, first column? First row, first column is here. First row, first column. So this is 1 1, M11. Okay. The minor is nothing but the determinant of order 2 except that element. Now what I mean by this, so M11 is this element. So don't consider this row and this column. So this is nothing but 4 3 2 1. So remember this, don't consider this row and this column because it is present in the first row and the first column out. So this is minor. Now how you evaluate it? AD minus BC. So if I see AD minus BC, 4 minus 6, answer is minus 2. So this is the minor of this element. So let us see the minor of the 2 3. Now 2 3, where are the position of the element? Second row, third column. This is first row, second row and third column. This is the element I am talking about. So its minor will be leave this row and leave this column where it is present. Leave this row, leave this column. So what is the minor? So look at this, leave this row, leave this column. What is left out? 1 minus 3 minus 1 2. Now you evaluate this, AD minus BC, you know it. So AD 2 minus 3, because minus and minus is plus. So 2 minus 3 is minus 1. Let us take 2 2. Now 2 2, where is the element here? 2 2 is over here, right? 2 2 is over here. So leave the second row and second column because 4 is the 2 2 element. So leave the second row and second. So what is left out now? Try to understand this. Second row and second column. 1 2 minus 1 1. 1 2 minus 1 1. Open up, same thing what you did before, that is AD minus BC. So 1 minus of minus 2 is 3. Now similarly let us go with 3 1. 3 1, can you tell me now 3 1, what is 3 1 is third row and first column. So third row, first row, second row, third row and first column. What is the minor of this? Leave this row and leave this column. So that is nothing but minus 3 2 4 and 3. So can you tell me what will be there? Minus 9 minus 8, right? Minus 9 minus 8. Minus 9 minus 8 is how much? Minus 17. Similarly, let us come to 3 3. Now if I see 3 3, right? 3 3 is here. So 3 3 is here. That is 4 plus 3, that is 7. Oh, sorry, I just wrote it out. 1 minus 3, 1 4, answer is 7. So what are these values? This is minor of 1 1. This is minor of 2 3. This is minor of 2 2. This is minor of 3 1. This is minor of 3 3. Now understand. So I understood what is a minor. Now I will tell you what is cofactor. You know how to find minor? You got the minor. I denote as M of any position. I am not worried. Okay. Now what I am talking is, I am talking about cofactor. I am talking about cofactor. So this is the minor here. When you put plus or minus sign to the minor, it becomes a cofactor. So what is this plus and minus sign? If you remember, when I was evaluating the determinant of order 3, if you remember, I had explained you all plus minus plus minus plus minus plus minus plus. When you put these signs to the respective position of the element, it becomes cofactor. So, I just give you one simple example. Now, suppose cofactor I denote as A. Okay. So, A, say ij, ith row and jth column, just a notation I put, okay, which is equal to minus 1 raised to I plus j into m. This is nothing but the cofactor. So, sir, what is the big formula? Don't remember this formula. This is just technical part I am explaining to you. Let us see how I get the cofactor for this minor. Okay. Now, cofactor I am showing in pink, okay, and minor I had shown you into green. Okay. So, what is minor? Minor is nothing but the evaluation of the elements of the respective position, and cofactor is putting the sign to this minor. Keep that in mind. Cofactor is putting the sign to this minor. Have a note. Take this A11 plus. So, plus into minus 2 is, so this is the cofactor. I am putting in pink. Okay. So, cofactor is minus 2. Okay. Similarly, let us come to 3 1. 3 1 is which element here? Third row first plus. So, minus 17. This is the cofactor of direct, there is no change. 2 3 is second row third column, there is a minus sign, right. So, minus of minus will become plus 1, that will become the cofactor. 3 3 is there plus, same thing. 2 2 is here plus, same thing. So, the cofactor is to the minor. Once you find the minors, you put plus and minus sign based on the situation. Now, every time I am not going to remember this, sometime I get mixed up also. Simple logic I will tell you. This formula I will apply here directly. See, if this adds up to even number, it will be positive. So, plus of minus is minus. If it add to odd number, it is nothing but minus. So, minus of minus is automatically become plus. So, this is mean by minor and cofactor of the elements. I hope you got this point clear. Be careful, this we are going to see very frequently in determinant topic. So, I want you to just understand it and follow it up judiciously. I hope you got this point clear. Okay. So, we will continue with the next part of what is left out. You saw what is the determinant, you saw what is determinant of order 2, you saw what is determinant of order 3, you found the method of evaluation of determinant order 2 and determinant order 3, and finally the minor and cofactor of the element. This is the funda. We are going to visit this again, so don't worry, you understood 20% or still fine, no problem at all. We are going to visit this again and again in the sums. So, for the time being, pause and note it down. This formula is simple. Now, for example, like 2 3, I will just make you clear. 2 3. So, actually it is 2 plus 3 is what? 5. So, minus raised to odd number is minus. So, in short, instead of remembering this formula, there is no need to remember this formula. Just see, if it happens to be 2 plus 3, 5 odd number, put minus. If it happens even number, put plus. That is the way it has to go. So, I hope you got this point clear. So, pause and note it down. Singular and non-singular, let us do this and then we will come back to the adjoint. Might be the adjoint we will take in the next session, because it is a bigger part and I want to do it in a cluster form. Okay, once you sit for the video lecture on the adjoint, we should do not only the example, explanation, but also the example, so that you come to know how to go about with these sums. So, singular and non-singular matrix. What is singular? A matrix A is said to be singular if its determinant A is equal to 0. Once this has come for 2 marks question here. So, what is the type of question? Suppose if I say that A is nothing but 2, 3, x, 4, and if I ask you that A is a singular matrix find x. Now, it is already specified that A is a singular matrix. That means what? It is equal to 0. The determinant is equal to 0. You know determinant is nothing but you are done in the determinant topic is equal to 0. So, how I get this up? So, AD minus BC. So, 8 minus 3x equal to 0. So, 3x equals to 8, x equals to 8 upon 3. So, this is the way type of sum which can come on singular and non-singular matrix. I hope you got this point clear. Okay. This ends our second session now, where we covered the transpose, symmetric and singular part of a matrix. All these concepts we are going to use in the end, where we use in overall, we will be doing the things on that. Okay. So, hello children, welcome back to the matrices topic. We are doing a very important part of matrix, that is nothing but adjoint of a matrix. Remember all these smaller concepts which we had studied in the previous 2 video sessions on matrices, and consequently this and the next session also. All these things will be utilized very drastically in the further part, in the end part of matrices, whose presence in the board exam is quite sure. So let us talk about this adjoint of a matrix. What is exactly adjoint? Adjoint of a matrix, square matrix, is the transpose of the matrix obtained by replacing each an element of A by its cofactor. If you remember this cofactor word, we are used in determinant. But instead of telling you this, I would use a simple word that adjoint A is nothing but cofactor matrix, its transpose. So, first find the cofactor matrix and transpose it, that's it. And we will give you a shortcut for it. We don't have to do the transpose will already be done automatically. So, what is adjoint A? Adjoint A is nothing but transpose of the cofactor matrix. Now, if you remember cofactor, I will just connect and take one example. You will come to know what is a cofactor. Now, suppose a matrix is given to you. So, 1, 3, minus 1, 2, 4, 1, 0, 3, 1, right. Now, you know they are the different positions of the elements here, that is nothing but A11, A12, A13, 21, 22, 23, 31, 32 and 33, so on, right. Now, you can find for every position of the element, whether it is A11, A12, A22, you can find the cofactor element of it. So, remember now, cofactor means to the minor, you put the plus or minus sign. So, this becomes the cofactor matrix. So, how I do it? So, let us see this part now clearly. Okay, now let us see this. Now, suppose if I want to find the cofactor of A22. Now, what is A22? 22 is here. So, leave this and leave this. So, A22 is 1 minus 1. The other elements you have to consider. Leave that row and leave that column. 1 minus 1, 0, 1. Now, A22. Let us find A22. You know any determinant is nothing but, you can say it's a determinant here. I'm sorry. Okay. So, 1 AD minus BC, 1 minus 0, answer is 1. Now, similarly, I have not done about the cofactor. So, just share with you later on. The cofactor element of the 2, this adds up to even number. So, this is nothing but plus. Or you always remember is plus minus plus minus plus minus plus minus plus. Now, A22 is plus. So, I am put the plus sign over here. Now, let us take A31. Now, if you take A31, 31 is this element. Remember, you don't consider that 31 element. Okay. Now, 31 means leave this and leave this. So, what is the left out now? A31 will be third row. Just cut this off and the first column. So, what is the left? 3 minus 1. This is left. 3 minus 1, 4 and 1. So, what happens over here? So, 3 ones are 3. AD minus of minus 4. Answer is 7. 3, 1. It adds up to even number. 3, 1. Look at this. 3, 1 is positive. So, positive 7. Now, let us take one more example. For example, say A11. So, 1, 1 is here, right. So, leave the first row and the first column. This part will come in the minor. that is nothing but 4, 1, 3, 1. Okay, so 4 ones are 4 minus 3, answer is 1. Now 1, 1 is positive, so it is positive 1. So this is the way you find the cofactor elements, by writing the minor value and putting the plus or minus sign based on this. Keep that in mind. Okay, so children, let us see a very important part in adjoint. So I had given a simple example. I had given the 2 by 2 order as well as 3 by 3. I will explain to you very properly this part, and you will come to know exactly what I want to share with you. So A is 2, 1, 4 minus 1. So find the adjoint of the matrix. So A 1, 1. Now what I do is, adjoint is nothing but transpose of the cofactor, right? So what I suggest is, this is A 1, 1. If you see this, A11, A12, A21, A22. Now, instead of writing and finding the cofactor element in this way, do the transpose here only. A11, A12. Here it is given horizontally, here you write vertically. So, similarly, A21, A22. So, A11, let us say A11 is this element, now there is this minus 1, right? But 1, 1 is even number, so plus into minus will be minus. A12, 1, 2, leave this part and this part. So what happens over here? A12, so A12 is 4, but remember 1, 2 is an odd number, so 1, 2 position is minus, so plus into minus is minus. A21 is this element, so remember A21 means 2, 1 is this element over here, so leave the second row in the first, so this is nothing but 1, 2, 1 will be minus, because if this adds up to odd, it is minus, adds up to even, it is plus. How do you follow that symbol? Anyway, now A22, 22 is over here, right? 22 is over here. So 22 is over here, 22. So leave this column and leave this row. So it is 2. So it is positive. So in short, remember the transpose is already done. So adjoint of A is given as minus 1, minus 4, minus 1, 2. Remember, this is the first row elements. The first row are already made the transpose by arranging in this format. So when I say A11, A12, A13, A11, 12, 13 has been transposed in A11, 12, 13. So that's the way you have to look into it. So directly you're doing, otherwise you have to find cofactor, then find the transpose. Sometimes you forget also to find the transpose and your sum goes for a toss. So instead of this, write this way. You will never fail. Now let's take the third. Here will be more clear for you all. Find the adjoint of matrix A. So what I'm going to do is, I'm going to say A11, A12, A13. Okay, right. Then A21, A22, A23. This is always better because you will not commit blunders. A31, A32, A33. That means I had already done the transpose. Now I will just find the cofactor element of this position of the element. A11, A11 is here. So it will take this element now, that is 3 minus 0, 3. I'll put the sign later on, right? 3. Then similarly, 3 minus 5, that is 3. Then A21, 21 is here. A12, 12 is over here. So first row, second column. So 2 minus 10, that is 2 minus or minus 10 is 12, right? Similarly, 1, 3 is here. 0, that is 6. Similarly, 2, 1. 2, 1 is this 2 here. So leave this row and leave this column. So minus 1. Then 2, 2. That is 2, 2 is here. So 1 plus 4, that is 5. Then 2, 3 is here 5. That is 3 plus 2. I mean to say, just stop this off, it becomes clear. Okay. Let us see this 3, 2, 3. 2, 3 is this element over here. So this element will become 0 minus 2, right? So minus 2, then minus 2 will become minus 5 minus 6 minus 11, then 0, that is 5 minus 4 is 1, then 1, it is 3 plus 2, answer is 5. Now remember, this is just the minor element and its transpose, but you have to find the cofactor. Cofactor means what? To the minor you put plus and minus sign. So this is plus, this is minus, 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 this is plus. So adjoint of A is nothing but 3, write in the same way as you got the answer. minus 11, minus 1 and 5. So be careful about this working of the sums. Let us take the next question. One more question I had put so that you understand adjoint properly. So as I said, the first thing what you will do, you will write A11, A12, A13, then is equal to, then A21, A22, A23, A31, A32, A33. So A11, now A11 is here, right? A11 is here. So leave that first one. So it comes to minus 28 minus 30 plus 30. So minus 28 plus 30, I think 2, right? Minus 28 plus 30. Then similarly, A12 is here. So minus 21, right? Then minus 1, minus 18. Then the 2 1 element is here, minus 6. 2 2 is here, minus 7. 2 3 is here, minus 6. 3 1 is here, 3 1 is here. So leave that part. 5, that is 4. Then minus 6, that is 5 plus 3, 8. Then minus 7, 4. Remember, this is just the transpose and the minus. Now you have to put the sign. Plus, 1 1 is plus. Now go in this order. Okay, plus, minus, plus, then minus, plus, minus, plus, minus and plus. So adjoint of A is already given to you. 2, 21 minus 18, minus 6 minus 7 plus 6, 4 minus 8 and 4. So I hope you got this point clear. Right? Given us, now look at the question here. In the beginning, when I mentioned this part, I have to explain to you. A into adjoint A is equal to adjoint A into A is equal to determinant to I. Now let us take an example. For example, let us take this part. I got A, I got adjoint A in this case. So I would just do for you A into adjoint A. Okay, A into adjoint A. Now I am showing you working over here. So okay, A into adjoint A. So I am just writing A into adjoint A in this case. A into adjoint of A. So A into adjoint A. So A is 1 minus 1 2, 2 3 5 minus 2 0 1, and adjoint is 3 1 minus 11 minus 12 5 minus 1 and 6 2 5. Now what I do when I multiply, look at this case. So it has become 3 plus 12 plus 12. So how much comes to see? 3 12 plus 12. 12 plus 12 is 24. 24 plus 3, it is 27. Right? Similarly, this will be 1 minus 5 plus 4, 0. This is minus 11 plus 1. This is minus 11 plus 1 and 10, 0. Similarly here, 2 3s are 6 minus 36. 6 minus 30 and plus 30 is 0. Then second row and second column, 2 plus 15, 17 plus 10, 27. This is 0. This is minus 6, 0 plus 6 is 0, 0, 27. So if you see this, this is 27 times I. Now this is what I am going to share with you. I just found for you this 27. Now I'll just copy this down. The determinant, the matrix A, this is the matrix A whose determinant will be, it is like this: 1 minus 1 2, then 2 3 5 minus 2 0 1. So basically what is this? I will share with you. Okay, now this is the thing. So let us find this: 1, right, then 3, then plus 1, then 2 plus 10, 12, then plus 2, that is 6. So see what happens over here, 3 plus 12 plus 12, it is 27. And what you got? 27i. So what is this? Basically it is determinant A into I. So therefore, A into adjoint A into A is same as A into adjoint A is same as determinant A into I. So why I showed you this? Because there is one specific type of question which they might ask you also. Now what is that question? For example, if I say, look at this, find A into adjoint A without finding adjoint A. What is this funny question? A into adjoint A without finding adjoint A. So A into adjoint A is there without finding adjoint A. So I do understand A into adjoint A is same as determinant A into I. So let us get determinant A now. So determinant A will be in this format. Determinant A will be equal to, that is minus 1 minus 2 minus 2. This is 2 1 minus 2, 2 minus 2 1, right, into I. So I is in the matrix. So let us find the determinant now. This is minus 1. This is 1 plus 4 5. I beg your pardon here. There is minus 1. Right, first element, you know how to do it. I am using the first row and opening this. So minus 1, this 1 minus 4 minus 3, right, then plus 2, then 2 plus 4, that is 6, then 2, then minus 4 minus 2 is minus 6, minus 4 minus 2 is minus 6. So what happens over here? 3 plus 12 plus 12, so it is nothing but 27. Is the same matrix we considered in previous? No, it's 27 which you got over here. Okay, oh my god, but I found the determinant A minus 27. So A into adjoint A into adjoint A is nothing but 27i. You can write in this format, or you can write like this: 27 0 0 0 27 0 0 0 27. So whatever you feel right, but see the question, how is very informal question this is. Nice one. So I hope you got this point of adjoint A, children. This is slightly difficult now, right? But you have to catch up with this. Practice some few sums at your end on all the topics, all the concepts we have done. And I don't think so there should be anything which can stop you further to understand the bigger concepts on matrices, which we'll be doing in the next session. So once again, thank you very much for being with me. Thank you very much. See you then in the next session. Good day.